Alright, time for another DraftPhysics.com, debatephysics.com also. And, well, we have a little bit of debate at least in the comment section, but again, comments aren't much of an argument. It's not much of a way to make a physics argument, frankly, but whatever. It's better than nothing. So we'll go there. Alright, so this is the Professor Lewin. This is the standard formula they create by making mv squared equal to mv. Yes, they make momentum equal to mv squared. But anyway, and make this Frankenstein. Okay, so this is the formula being used, okay, to decide elastic collisions. So it's supposed to be collisions that are just merely elastic, not ones with necessarily springs. They have the idea that springs do the same thing. They make things elastic. But it's not the same. So that's a contention I'm making. Okay, you have to counter-argue it with some evidence that springs don't change experiments from elastic to something else. Okay, that isn't exactly. The results aren't going to be the same. You use a spring in a Newton's cradle, it's going to do something different than if you don't use a spring. And that, I'm arguing, is a fact. All right, so yeah, so I'll read a little bit of his comment and then make the argument. Please watch the video. You make the claim about what the conventional theory says, and when I tell you it's not what the theory says, you ask for experimental evidence that doesn't happen. What? I'm asking you to produce experimental evidence. Isn't that seems a perfectly fair thing to do? You say certain things happen. I'm saying they don't happen. You know, and the only way to solve it is experiments, but frankly, nobody will do. Your people won't do the experiments. So let me get this out of the way, and I'll just say, okay, this is the formula. All right. And if you just write it out, what all the masses will do, all right, you know, you can just fill in the blanks for the formula. You know, 1 to 2, 1 to 3, 1 to 4, in terms of changing the masses. All right, and you can just get this standard kind of configuration of numbers that you're going to get as a result. And the simple argument is that you know, their numbers mean, all right, I have 133. So whatever number I have here in terms of a percentage of how much energy is reflecting. So I throw something and I get a reflection. Whatever that reflection is, I get 100% plus that percentage going forward. So the argument they're making is that if I can make something reflect off of a surface, bounce off a surface, I can put twice as much, technically, energy into the surface, up to twice as much. Okay. So it could only be 33% more, or it could be 50% more, or it could be 60% more, or it could be 70% more, 70 there. And you can just see it incrementally gets tighter and tighter, and you have to go to like 100 times the weight before you're at something really close to 200. Okay, so at 80%, you're at 180% more momentum moving in the direction. So if I throw something and it sticks, I only get 80 or 100, right? If I throw something and it sticks, I only get the same momentum I put in. But if it doesn't stick, I get more energy going forward. Now, if that might make sense to you, but obviously that makes no sense to me. So I'm saying obviously a reflection is real motion in the universe. You can't have a reflection and give the thing energy. Can't do both things. And I think that's just an obvious truth. So I would argue that these are the accurate numbers that you should expect if you were to do the experiment. So I didn't write this very well. So this would be a 1 over 1 here, and then this is 1 over 3. You know, 1/3 of the energy goes forward when it's 1 to 2. And then when it's 1 to 3, it's 1/4 of the velocity. So 1/4 of the velocity in a 3 mass is obviously 3/4 of the momentum, not 3/4 of the velocity, as they claim. And 1/4 of the energy comes back. So they both go the same. So the argument is if you do this with a Newton's cradle with this gradually increasing mass, that what you will end up with is the same velocity going both ways. So it happens in the 1 to 3 mass, we know for sure. And all we need is the test of the 1 to 2 and the 1 to 4. Will they fly off at the same velocity, then collide, and we get 100% back again, and it comes in, does the same thing all over again? And that would be my argument, what will happen, especially when you use springs. So if you use springs on carts, you're going to get, just this simple 1/4, 1/5, 1/6, 1/7, always one fractional unit less than all of the momentum, and the other bit will be in the reflection. And that's what's going to happen in elastic collisions. All right, so now the part that he's correct about is that there was an error in what I said in this sense, but he didn't point it out. But it's a relativity argument. It just has to do with the relative velocities. That if I did put something between two objects that just bounce back and forth, like two ambles, and I have them in space, and I just throw something, and I get 100% reflections. The fact is once they start moving, okay, relativity is going to get in my way, and the relative velocities are going to change, because when the ball bearing's moving this way, the thing is also moving this way, and that's going to diminish the relative difference. And eventually the ball bearing, when it reflects, okay, technically will still be going in the same direction as the object it reflected off of, and it will never hit the other one. So you can't grow the energy all the way to the speed of the object itself. But again, it's a technical point. It's still free momentum. You're still creating a lot of energy, and we could just change the experiment to the one where we just take balls that weigh 10 times as much as the one we're going to swing on a pendulum. All right, and we just have a feeder, okay, where these will just push in, and then we just have a little pendulum here, and it swings in 10 times the difference in the mass, or let's say 20, because then we're closer to, we're like at 193 or something % of the energy will be transferred with each hit. And so, so I just swing this pendulum in, okay, and it hits this one, gives it 190, let's say, % of the velocity, the momentum, and it comes back with 90, okay, %, and then it hits this one, and this one goes with, 100. It'll be 190% of 90%. So, it'll be, let's say, 170% of the original velocity, and then this one will come and it'll go 150% of the original velocity, and then 30, and it'll keep declining. But when you total it all up, you're going to end up with like 1,000 times, more, 100 times more energy than you put in. Where's the cap? Well, it doesn't really matter. So again, just logically silly that you could use the same energy over and over again because you're getting this gigantic reflection. So again, the simple argument I'm making is that if I hit something like a cart on wheels and I hit it with a rubber ball, I'm not going to be able to get the thing to move and get a reflection. The more it moves, the less reflection I'm going to get. So the more the cart moves, the less I'm going to get as a reflection. So as I make the cart heavier and heavier, and it moves slower and slower, it's still eating a percentage of the ball because it's a spring-loaded kind of thing. So it's still going to go into it as long as it moves. And it's not until it doesn't move that I get a reflection. So the more it doesn't move, the more reflection I get. The less energy I put into it, the more reflection I get. It's just that simple. If I throw a rubber ball at a wall and the wall yields, I'm not going to get the same bounce out of the ball. The more the wall yields, the less I get back. I'm just saying that's an absolute fact. I can't get more back and make the wall move. Do I need any other examples of why this is nonsense? All right, so let's just, I can play the clip from Professor Lewin that he also raises. So let me read further into his comment. And we'll put this back and switch the position of the video. When Lewin said you should have a sleepless night over it, the trick was that the wall had infinite mass. So again, what's the difference? Not moving versus infinite? Is there some difference? Especially when it comes to Professor Lewin's explanation, which he doesn't give in the video, but he does give an aside thing where he says basically the Earth moved. Okay, in reality, you don't have objects with infinite mass. The ball bearing can make something move and keep its kinetic energy. So that's what you're saying. I'm saying that that can't happen. You can't get a 100% reflection and put 200% of the energy into the wall. Can't be done. That's where you create free kinetic energy, even after the first bounce. I don't understand how you can claim otherwise. I don't understand what you're even claiming here. The ball bearing can't make something move and keep its kinetic energy. What do you mean? It doesn't make any sense. I mean, I'll play the clip. I mean, Professor Lewin's saying it's twice the momentum went into the wall. He's saying it happened. And he's saying it really did move the whole Earth. So how the fuck have you done that argument? You haven't done anything to it, to change anything. So it says here, in your example with a spring attached to the wall launching something, the ball would gain the same amount of momentum in the opposite direction. So again, the immovable object moves. It doesn't. Of course, if the wall is attached to the Earth, the velocity would be so tiny in most cases you can ignore it. Well, we're not talking about whether it's so tiny you could see it. We're talking about whether it actually happens. That you can move something and get your energy back and just do it over and over again. Oh, God, that's so stupid. But it's still there. Equal and opposite. The whole point is there's nothing equal about creating free momentum in a direction. So again, you can keep saying it's some sort of equal. There's nothing equal there. Always. No hypocrisy here. Well, bullshit. It's not Newtonian physics. Newton didn't believe it. I can't believe you're trying to argue that Newton didn't say direction matters when conserving momentum. It is written in his book, which is available online. So he puts that in capital letters when we've already been over what's in his book. So go ahead and show me the sentence that talks about mv squared anywhere. And then tell me where he says it takes, that twice the velocity is 4 times the force. And or somewhere where it's not in this convoluted statement where he says, if I may say so. So again, if you read the text, it's not clear at all what Newton's talking about. He's giving examples, all right, to shorten the argument instead of giving you the statistics he actually observed. So instead of telling you what he actually observed, he's describing it in an idealization. And that's an error in his book, frankly. By perfect spring, I mean a spring that gives all its energy to objects it is pushing. It has no mass of its own and doesn't generate heat, etc. Well, it's not really so much the mass of its own is important because the mass is still moving after the object leaves the spring, and that's a really important fact. That if the spring is still moving after the other object leaves its spring, then obviously the spring hasn't given back all of its energy, and that's a reality. And if you're going to use idealizations, I'll just throw the lever balance at you again, the gravity balance, and just say the gravity balance proves absolutely an ideal gravity balance. You can put the recoil of the gun in one side and you'll get the bullet out the other side. Exactly the same amount of energy. By the way, since you have done some animation simulating charge, it's a simulation, it's not an animation, but anyway, here's an idea. Make an animation simulation, the pendulum collision with 1 and 3 mass objects. Why? I mean, why shouldn't these experiments be done? Why should we have to simulate them? And of course, it's just going to matter on what math I use. If I use my math, the two things hit each other, they move away at the same speed, and then they do that. And they just keep doing that over and over again. So just like the 1 to 3 mass, all the other masses will do the same thing. One according to the conventional physics and one according to your physics. So again, what's the point? I mean, it's something you can just understand by drawing it. I don't need this. I don't need an animation. Okay, then you will see. What will you see? You're not going to see anything. Mine will look exactly like 1 to 3 mass one that we have video of. What will yours look like? Okay, the one looks like something can happen in real life. The other one will look silly. Says you. Seriously, do this. Fuck you in the ass. You do it. There will be a clear difference. Fuck you again. There won't be. I mean, there'll be a clear difference in the two arguments being made, and the only difference is going to be is what you claim the velocities to be. You can also compare the animations to the videos you have seen. So this is more nonsense. If there were videos, I'd be showing them. Okay. I can also try to do it when I have more time. Yes, why don't you do it? All right. I mean, wouldn't it be more sensible to actually do the experiments in a nice clinical way? I mean, what's the big deal? Pendulum. Okay, 1 mass against 1 mass, 1 mass against 2 mass, 1 mass against 3 mass, 1 mass against 4 mass. Just like the car crashes. Is there any doubt? We already know what the outcome is going to be. We can smash the car at 25 miles an hour, and then 50 miles an hour, then 100 miles an hour. Well, 75, and then 100, and we're going to find out that twice the velocity, twice the impact, 3 times the velocity, 3 times the impact. That's what's going to be found out. You're not going to ever show this 5 times bullshit. So this idiot says the fat of, whatever that is, fatto, something. He removed your comment. Yes, I read it in a video and responded to it in detail. Okay, from the last video. It has lots of likes. Well, that's really important. It's the number of likes it has, isn't it? That just indicates the troll nature of you weak asses. You're all such cowards. You proclaim this crap from anonymous bullshit sock accounts. You just have no guts at all. Why don't you put your name on it, all right, so we can appropriately have you pissed on in the future, because you're just an obstacle to fixing what's broken. I mean, obviously the physics is idiotic. Throwing a rubber ball causes more momentum to go into an object than throwing a steel ball. I mean, it's too ridiculous. If the energy is absorbed by the object, so we're in space, here's something, it's rubbery. Okay, I throw the thing and it's rubbery in the sense that it'll absorb the energy. It's gluey, and so the thing hits it, they're absorbed, they go off together, and I still have 100% of the momentum. But instead, I make it so it's elastic. I put a spring on it, and I throw the ball in, and I get 180% or 190% of the momentum. A doubling of the momentum going that way, and I get my ball back. That it can hit again and just bounce that way again. So I can just keep adding energy in that direction. So I can just let the reflected ball hit and bounce back in the same direction, and now I have 3 times the momentum. Okay, so I started with 100%, and I'll have 300% going that way, right? So I just throw it and then put a reflective wall up. Okay, it bounces off my wall and still going that way. So I have a 1 mass going with 100%. I have a 3 mass going with 200%. I have 300% of the momentum I started with, going in the same direction. That's your physics. Just like 25 times the fuel to spin something 5 times as fast. That's what your formulas say. And it's not true. And here you're continuing to belligerently defend this crap, this nonsense, this idiocy. Alright, so let's just play the Lewin clip. Not there. Should be here, maybe? Alright, so we jump to about here.
We cannot wake up the morning after election day wishing we had done more.
And
the truth is
blah, 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 blah. You both suck.
Now, I want you to have a sleepless night. I want you to think about the following. And if you can't solve it before the night is over, then I really think you should lie awake.
So, yeah, that's some setup, and then he's not going to give us a punchline. That's the funny part.
Here is the wall. Here is a tennis ball that comes in with a certain mass m, and it has a certain velocity v, whatever that is. It's a nearly elastic collision, and it bounces back from the wall. And we all know that if it's a nearly elastic collision, that it comes back with the same velocity.
Right, okay, so it comes back with the same velocity. Now, if the wall yields, okay, and that is, so less than twice the momentum goes into it, then somehow I get less of a bounce back. And so the less energy I put in the wall, the less energy I get back. But it's still twice as much energy.
Kinetic energy is conserved. All the kinetic energy is in the tennis ball. Nothing is in the wall.
So again, kinetic energy is conserved nonsense, and this argument is that somehow this direction matters. When we change things direction all the time, you throw something up in gravity and it comes back down in a different direction. Do you think gravity did twice the work? That somehow twice the work was done on the object? No. Gravity's conservative. Gravity gave back what you put in. Nothing more, nothing less. Changing direction does not cost energy.
An infinitely large mass. But the momentum of...
So, of course, it doesn't have to be infinitely large. It just has to be an anvil or something else that won't move.
This tennis ball has changed by an amount 2mv. That momentum must be in the wall.
So he says it must be in the wall. Because, well, and it's not moving, though. So it doesn't make any sense, right? Somehow it absorbed momentum. That is, it's a mass moving a velocity. See? I mean, what's the point of this physics? Why this kind of nonsense? You're telling me that I should in some way understand that this is somehow a rational thing to say, that twice the momentum went into the wall when there's no evidence the wall's moving at all. It has no V, 0V, and yet you're claiming it's there. Well, how can it be there if there's no velocity?
Non-negotiable, because momentum must be conserved. So now here you see in front of your eyes a case that the wall has momentum, but it has no kinetic energy. Can you understand that? Can you?
No, it's nonsense. It's baby talk. Okay, first off, it doesn't have any momentum, and it doesn't have any kinetic energy, and all the energy just got reflected, and that's all that happened. That's all that took place, was you just threw it at something that wouldn't accept the energy, so it just said, here, you can have it back.
Reconcile that? Can you show me mathematically that that is completely kosher, that the wall has momentum 2mv? It's non-negotiable.
I mean, it'd be interesting if they could make like a really good hardened steel bullet and hit it against a very hardened steel target, okay, and see how much of a reflection they can get out of the bullet, and how much energy they can put into this hardened steel object.
Must have momentum, and yet it has no kinetic energy. How is that possible? Think about it, and if you can't solve it, call me at 3 a.m. and I'll tell you the solution.
Yeah, right. So isn't that bullshit? I mean, that's just bullshit, right? I mean, just waste people's thought processes with this. Oh, I'll pose a problem and, not tell you the ludicrous answer, which is, well, the infinite mass did actually move. I mean, it doesn't matter whether I make it an infinite mass or I tie it to something really large. The argument is that it did actually move. It's a very small amount of movement, but it moved. It does have it has a mass and a velocity. And all it did was move with twice the momentum. So I actually gave it twice the momentum I started with. I started with a certain amount of momentum going this way. I gave it twice the momentum. And I got my thing back. So again, it's just bullshit. So again, there's nothing, what are you going to do with these people? They're just going to keep defending crap. Okay, they really believe it takes 100 times the fuel to go 10 times as fast. And you could just make the number sillier and sillier and sillier. And it's bullshit. I mean, how many ways can you... I mean, I've gone through so many, again, the ballistic pendulum is just so obvious. There's just nothing in the annals of physics where they've been able to collect their kinetic energy. If you can't collect the energy, you can't locate it and show it to exist, it's not energy. All right. And the fact is the fact that they can only collect 0.06% of the kinetic energy of the bullet. All right. 99.94% missing. Come on. It's not real energy. But whatever, though. There's no point doing this because people are so fucking dumb and dishonest and corrupt and shitty. I mean, goddamn. Anyway, humans just suck. Alright, so do I really have to do anything else to... I mean, there's no point in making all the... I mean, I could go through the lever thing again, go through all these arguments that none of this crap can be true. And why are you assholes defending it? Alright, I'll pause and see if there's anything else to say. No, I thought of something. I mean, so let's say you need to stop an intruder, okay? And the fact is that you could make him fall backwards, So it's not so much about injuring him. It's just about giving him momentum and making him fall into the, fall down the basement stairs. Let's say he's right on the edge of the basement stairs. And all you have to do is give him some momentum and he falls. Your argument is that if I shoot a regular arrow at him that penetrates and stays in his body, I only give him the momentum of the arrow. But if I hit him with a rubber arrow, okay, that bounces off of him aggressively, I put twice as much energy into him. That's your silly, idiotic, moronic theory. Okay. And you're going to insult my intelligence by saying, why don't I see how obvious that is? Yeah. Amazing. So, anyway, till the next time and such and so forth and whatnot. I think that's all there is, really. I thought there was a side subject. Well, I'll pause again. Alright, so I think that's it. So, till the next time and such and so forth and whatnot. Blah.